Hello everyone. In this lesson, we are going to learn about the new cell map. So our aim is to create the cell map, uh, which is based on the quad mesh. So in earlier lessons, we have learned different types of cell maps, so that we can easily create different types of periodic lattice structures using that particular cell maps. So in this lesson, we aim for creating the cell map by using the quad mesh. So I will show you what are the steps involved in that, and what are the parameters, input parameters we need to define them, and how we can tune them. So all of these things we are going to discuss in this lesson. So by the end of this lesson, we will learn we will learn about different parameters which are required for defining the cell map, so that we can easily create the different types of periodic lattice structures. So let's start. Okay, as we know that before starting any file, so let's give the notebook name as cell map using quad mesh. Okay. Okay, fine. So if let's give the description as um, the generation of cell map using the quad mesh for creating the periodic lattice structures. Okay, so let's give the section name as cell map using quad mesh. Okay, so as we know that, so we can find this cell map using different ways. Okay, the first way is that either we can search from this add block by pressing Ctrl L R, or directly we can search here like cell map. So here we can see cell map between CAD faces. We have discussed this earlier lessons, even this cell map from one single CAD face. So in this lesson, we are going to learn about how to create the cell map from quad mesh. So here it is saying that creates a cell map that is conformal, okay, to a quad mesh. So note that underlying UV field properties will not be continuous. Okay, so let's select this. So here, this is the one method to get the cell map from quad mesh block. So again, another method is that from ribbon, this ribbon, we can get it from lattices tab, and there we can go to the cell maps tab. So here we have different types of cell map which are present within the nTopology. So in earlier lessons, we have discussed regarding the rectangular cell map, cylindrical cell map, spherical cell map from single CAD face, cell map between the two CAD faces. So in this lesson, the final one, that is cell map from quad mesh. So let's select this. So in this way, we can get this cell map from quad mesh block in two different ways. Okay, so let's select only one. So let's delete by pressing the delete button. So now here what do we observe? We need to define three different parameters. So what are they? One is surface mesh, and second is height. So up to which height we need to create the quad mesh, and the layer count. So given layer, given height, so how many counts we need? Okay, so I will explain you what exactly that means. So before that, here we need to create the surface mesh. Okay, so you will learn about the meshing later on modules. I will explain you. I will create a different video on different meshing techniques. Okay, so before that, so here as we are using the quad mesh, so we need to select the quad mesh related thing only. So let's double click here. So here we have different types of input parameters. So as earlier we used to use mesh from CAD body, mesh from implicit body. So so we need to select quad mesh only. So here we have different type of mesh. So here quadrangulated mesh. Okay, so that we need to select for today's lesson. So let's select this quadrangulated mesh. So then only we can able to perfectly use this cell map from quad mesh block. So let's select this again. So after selecting this, what do we observe? We need to define different parameters. Okay, here we have to define the different parameters. So just wait. Yeah, here we need to define these many parameters. So okay, what are they? One is mesh. So we need to create the mesh for a given body. Either it can be CAD body or it can be implicit body. Okay, but it must be implicit body. Even though it is a CAD body, we need to convert that into implicit body. And second is target count. This is a major parameter which influence more to get the accurate or this is the one of the major important parameter, just keep in mind. Okay, and next is we need to define the adaptivity, so we will play with this parameter as well. And sharp features, so if somebody wants, everybody wants sharp features only, so let's check, we can check this only. And okay, so let's go ahead. And here feature angle, it is up to you. If you want to give, you can give, otherwise there is no need. So as nTopology by default it is suggesting as optional, so let's leave them. And now that this is the one of the parameter surface mesh, so let's define this one by one. So let's give this mesh. So here you can click this. As we know that we are going to select the implicit body. Okay, so before that, as we have here different types of input parameters, so in today's lesson we are not going to take any CAD body, we are not importing any CAD body, we are only considering the implicit body. So let's select that. We are going to create the implicit body, and from that we are going to create mesh. Okay, so let's select this. Again, here we need to define various parameters. What are they? One is body. So for that we need to select the body. It is up to you which body you want to give. Body means it can be cube, it can be cylinder, it can be sphere, it can be torus, it can be conic cone. It is up to you. Either you can import from inside, from if you have any other body you can also import, there is no problem. Okay, and we need to define the tolerance value. It is in mm. Okay, and minimum feature size, it is up to you. If you want to give it, you can give. And if you want to use sharpen or simplicity, then it is up to you. So in today's lesson I'm not going to touch them. I'm only focusing on here two major parameters. One is body and second is tolerance. Okay, so let's give the body. Here either you can directly press. So in today's lesson I'm going to select the cube only. Okay, either you can type cube. Okay, so like that you can get it, or you can get it from primitive tab here. Okay, you can go to create and then you can go to primitive, and from here also you can select. So like that you can get it outside. So you can make it variable and you can place it inside. Okay, I will show you what exactly means. So let's make it variable and give the name as cube, because you can use it again and again if you are going to use. So it is better to make it variable. And as I said, you can remove this by pressing the delete or okay. Now you can just drop this in this block. So we have placed it. So here, what do we observe? It's the center point is here. Okay, this is our center point. If somebody wants to change, they can freely change. And it's a size is 10 mm, 10 mm, 10 mm. So if somebody wants more than that or lower than that, so they can just simply vary by changing the values. It is up to you. But always keep in mind that it must have the units. Okay, so now let's move ahead. Let's give the tolerance value. So as we are creating the mesh, it is better to uh, go from the higher values to the lower values. So when we are creating any mesh, so let's give the higher value, like tolerance value can be 5. It's just for timing you can keep it. Now just minimize this. Yeah, this is our quad mesh. So yeah, although it is not perfect as like cube, so to get the perfect shape you can just tune this value like 1. So this is somewhat almost accurate as a cube. So let's go ahead with this. Yeah, here as I said that we are using quad mesh. So here we are able to generate the quad mesh. Okay, so this is how we can generate this quad mesh. Now target count. So here by default nTopology is suggesting us 200. So if somebody wants lower than that, they can freely give the value. And if somebody wants more than that, they can freely let's give the value 100 and see what is going to happen. See, have you seen this? The size of the mesh is increased. Okay, so let's go ahead with 100 only. And I'm not going to change the adaptivity. I don't exactly. Let's see what is going to happen. So it means I think, is there any major deviation? What it is saying, there is a error. Adaptivity is a percentage in range 0 to 1. Okay, so we must define this like 0.9. So there is no much effect, so let's keep it 0.1 only. Okay, so till now we have created a cube with a tolerance of 1 mm and with a target count of 100. So let's move ahead. Let's minimize this. Now we are not defining a feature angle and symmetry. So let's keep as it is. So we have defined finally surface mesh. So what exactly we did here? There we have defined various parameters such as mesh, and only mesh is the major parameter as I said. And in mesh, the body and tolerance are the main parameters. And in surface mesh, another parameter like target count is the most important parameters. So till now we have defined those two parameters. Now the let's minimize this. Now two important parameters left. So what are they? Height. Okay, just place this cube above this so that we have like continuity. So now height. So here it is showing in the mm, so we must define that in mm. So let's give height as a 1 mm. Okay, and okay, now we need to define layer count. How many counts you want? For example, let's give the count number 1. Have you seen this? What happened here? Now our cell map is created based on the quad mesh. So if you want to see the exactly, so this is our cube. Okay, and it is created with respect to the its outer boundary. Okay, based on the given tolerance value of the mesh. And this is how one can able to create the cell map with respect to the quad mesh. If somebody wants to create the periodic lattice within this given cell map, they can freely create it. I will show you also. Okay, so this is how one can create it. Now we can play with the parameters such as let's make it this shape so that we can find the difference. Now just have a look on this. This is the height we have given, we have defined, and the number of layer count only 1. For example, if I increase the layer count as a 5 and see what happened here. So now the layer count is increased. Okay, if so for example, if I'm going to increase the height as a 10 mm, see, this is how one can able to design the cell map with respect to the quad mesh of a given body. Okay, so one can fill the lattices within this given quad mesh. Okay, so hope that you have understood till now for to how to create the quad mesh. So till now what we have done, we have created the surface mesh. Okay, and we also defined two other parameters such as height and layer count. So now we finally created the cell map. So let's go ahead with the cell map of like 3 mm. Oh, sorry, 3 mm. It's too high huge. And let's have the layer count as it is as a layer count. Also we can go with the 3 mm 3 counts. Now let's minimize our cube. Now so see, if you want to see the it's a cross section view, you can also see. Okay, this is how you can able to see the how this there is a halo inside the body. This is our cube body. So we are going to create the cell map within this only. Okay, so now we are going to fill our lattice unit cell within this. It can be surface based or it can be stud based. Okay, I will show you how exactly we are going to create this. So finally we have generated the cell map. So let's move ahead to create the periodic lattice. So for that, what exactly we need to do? For that we need a periodic lattice block. How can we get it? We can get it by simply search from here like periodic lattice. Okay, so here we got it. Now another method is that simply just go to lattice tab and again further move ahead to lattice, and here you can get it. Okay, this is how you can get this particular periodic lattice block. Let's delete one of them. Now here what are the parameters we need to define? Three parameters. What are they? The unit cell, type of unit cell we are going to use. It can be stud based, it can be plate based, it can be the surface based. And now we need to define cell map. That is we already defined. And the third parameter is that unit cell parameter. It is based on the unit cell we are going to use. For suppose if we are using stud base, then we need to define the diameter. If we are using surface base, then we need to define the thickness. And if we are define the plate base, then we need to define the thickness. Okay, plate of the thickness. So likewise, we need to define each of these individual parameters. Understood? So as we created the cell map, so let's place this cell map here. See, after once we drag it automatically suggesting that you just place this, you just drop it here. So let's drop it. Okay, lovely. Now our duty is to we need to define type of unit cell. So do you have any in your mind? Please let me know if somebody wants a different type of unit cell in comment. Okay, yeah, let's let me for simplicity let's use surface based only. So just press it here, double click. Here we have various types of unit cells. Okay, so as I said, we are going to use the walled TPMS unit cell. That is lovely one. Okay, so let's select this. Again, to define unit cell, again we need to define various parameters. What are they? We need to define type of unit cell. As nTopology by default it has different type of unit cell, that is surface based unit cells. So as I have discussed about these things earlier lessons, so here you can get it by simply pressing here. So total how many unit cell do we have? 6 unit cells. So our favorite one is gyroid one, so let's pick that. So this is our gyroid unit cell. Now it filled within the given the body. Which body? That is our cube. So its size is now 10 mm, 10 mm, 10 mm. So but our goal is to fill this unit cell within the created cell map, not within cube. Understood? Okay. Then we are not going to touch orientation because there is no much effect of this for this cubic symmetric unit cell. It has only effect on the non-cubic and asymmetric unit cells. For suppose 2D unit cells like honeycomb or reentrant or other any kind of acidic structures. It is up to you. But for now, we have only cubic symmetric unit cells. So let's go ahead. There is no change. So exact thickness, it is up to you. If you want to use it, use it. Otherwise, no. Yeah. Okay. Now we have defined our unit cell, and we also defined unit cell map. Now our goal is we need to define the unit cell parameter, that is thickness. How much thickness? Yeah, here it is saying in mm. How much thickness do you need? So let's go with the lower thickness value like a point like for suppose point 1 mm. Yeah, let's go ahead. So be ready. Okay, now we are going to see the magic. Let's wait. Now it is creating. Just wait. It will create the magic. There is some warning came. No worries. I think it will take a lot of time. So I think we can go for higher values. Oh, yeah, yeah. I understood. Why? Because we have mentioned one more thing. Exact thickness. Just uncheck it. Now, just wait for some time. So this is the effect of exact thickness. Okay. Now you are going to see the magic. Have you seen this? So do you observe anything before creating this? What is that? The parameter exact thickness. So if somebody uncheck this, okay, then you need to wait for a long time. So it is up to you. So it has much more effect on duration of creating the given cell map. Okay, yeah, just leave it. Now here we have created the beautiful structure using the gyroid, and it is created within our cell map. So lovely structure, but there are some deviation. It's okay, you can just simply change the value of 0.25, that lovely value. Just press it. Now we are going to see the beautiful structure of gyroid within our given cell map. I hope you are understanding this. See, this is our beautiful structure which is created and which is filled within our cell map. Understood? So let's highlight the cell map. So this is our cell map. Okay, have you seen this? So each of the unit cell filled within this cell map, and I can show you one more thing. It's cross section view. Oh wow, what a beautiful, isn't it? See, our inside is it is empty, and it exactly fills within a defined cell map. And here it has a different, see how many layers. So layer count, based on that it defined three counts. Okay, now finally we have created the periodic lattice structure using what may cell map. This is the beautiful structure and lovely one. I hope you enjoyed this. And now your duty is play with the parameters. So it is up to you. So as I said, there are various parameters such as, for suppose, if you consider the cell map itself, you can play with the height of the parameter, height, and you can play with the layer count. You can also play with the thickness. If somebody want higher density, then they can increase the thickness value. If somebody want lower and higher porosity, they can decrease the value. And if somebody wants more height value and further target count, for suppose if I'm going to increase the target count 1000, then let's see for the beautiful structure. Okay, now we are going to see the magic. Okay, it is creating. Let's minimize this. Creating. Okay, yeah, because as we defined, see, the beautiful structure is created. What a beautiful, man. Wow. See, you can now play with the unit cells also. Not only see how exactly it is filled. Now, if you play with the tolerance also, so what do you think? Huh? Let's play with the tolerance as well. If we play with the tolerance, then it will take. So hope, so you like this, you can play with the various parameters, unit cells as well. And here, as we used only surface based, now you can also play with the surface based, strut based and plate based. So let's see its cross section, we see how beautiful it is. So this is how one can play with the unit cell. I hope you understood till now and you enjoyed this video and you have learned something. So now I'm going to conclude this. So in this lesson, we have achieved the creation of like a cell map, periodic unit cell, gyroid periodic unit cell, especially using the cell map that is generated based on the quad mesh. So here we have defined various parameters, okay, such as target count, mesh. We have used only quad mesh, and there we have defined the cube body, and we define the tolerance and also define the target count. So this likewise you can play with these parameters, these three parameters. And we also defined height and the layer count and thickness. So finally we have generated the beautiful gyroid periodic lattice using cell map from the quad mesh. So I hope you have enjoyed. If you have any doubt, please let me know in the comments, so I will try to clarify them. And I hope you enjoyed this lesson. And I'm going to give you the homework or task. You can play with the parameters and generate the lattice structures and go for playing with them and enjoy this. So finally, I'm going to conclude. I hope you have enjoyed. Thank you.